A microservice using MongoDB crashed every 6 hours with OOM-Killed. The container had 4 GB RAM, but the dataset was only 2 GB. The team assumed a memory leak, but the real culprit was WiredTiger's default cache size. Let me show you exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover NoSQL store types compared. NoSQL stores are non-relational databases designed for specific data models and access patterns. They trade ACID guarantees for horizontal scalability, flexible schemas, and high throughput under specific workloads. The 4 main types are key-value, document, column family, and graph stores. Each is optimized for different use cases. Key-value stores are the most basic NoSQL type. You have a key, you have a value, that's it. The value is opaque. The database doesn't care about its structure. This simplicity gives you insane performance. Redis can do 100K plus ops sec on a single node, but you can only query by key. Here's a Redis rate limiter using sorted sets. It maintains a sliding window of 1 minute, allowing up to 100 requests per user. The key is the user ID, and the value is a sorted set of timestamps. Document stores like MongoDB store JSON-like documents. Unlike key-value, the database understands the document structure. You can query on any field, create secondary indexes, and run aggregations. This flexibility is a double-edged sword. Without a schema, you can get data inconsistency. Here's a product catalog with dynamic attributes. We insert a laptop with varying fields, then query for laptops under $1,500 with 16 GB RAM. Document stores shine for semi-structured data. Column family stores like Cassandra store data in rows, but group columns into families. They're optimized for write-heavy workloads and wide column schemas. Data is partitioned by row key and sorted within a partition by clustering columns, making range scans fast. Here's a time series data model for IoT sensor readings. The partition key is sensorid, and the clustering key is timestamp sorted descending. This allows fast retrieval of the last n readings for a sensor. Graph stores like Neo4j store nodes and edges. They excel at traversing relationships, finding friends of friends, shortest paths, or influence patterns. The performance advantage comes from index-free adjacency. Each node stores pointers to its neighbors. Here's a social network graph. We create users and friendships, then query for friends of Alice, excluding direct friends. Graph stores make this traversal efficient. NoSQL isn't always the answer. If your data is highly relational with complex joins, referential integrity, and ACID transactions, a relational database is still the right choice. PostgreSQL with JSONB can handle many semi-structured workloads without the operational complexity. This is the same issue we highlighted at the start. Here's exactly why that happened. The container had 4 GB RAM. MongoDB's WiredTiger cache defaulted to 50% of RAM minus 1 GB, about 1.5 GB. But the working set was 2 GB, causing constant page faults and cache eviction. The OOM killer fired when the OS page cache plus MongoDB cache exceeded RAM. The fix was to set WiredTiger cache size GB to 1, which is 25% of RAM, leaving room for the OS cache and other processes. Also enabled compression with zlib. This prevented the OOM killer from firing. MongoDB's memory usage is not just your data, it's cache, journal, and connections. Always reserve 25–30% of RAM for the OS and other processes. The default cache size can cause OOM if the working set is larger than the cache. If you don't set maxmemory-policy LRU, Redis will OOM when it hits max memory. The default noeviction policy returns errors on writes. Always set an eviction policy in production. Document stores are terrible for joins. MongoDB's lookup is slow and doesn't scale. If your data is highly relational, use a graph store or PostgreSQL with JSONB. If you use a low-cardinality partition key like sensor type, one partition can grow to gigabytes, causing read timeouts and compaction storms. Always ensure partitions are bounded, e.g., by time bucket. The article mentions setting maxmemory-policy LRU for Redis. In Redis 6 Plus, the default no-eviction policy returns errors on writes when memory is full. For production, always set an eviction policy appropriate for your use case, such as all keys LRU for caching or volatility TL for session stores. The article warns against unbounded partition growth. A concrete solution is time bucketing. Partition by a time bucket, e.g., day, to keep partitions bounded. Here's an example schema for sensor data bucketed by day. The article's incident shows the importance of WiredTiger cache sizing. In production, monitor WiredTiger cache metrics via DB server status. If bytes currently in the cache exceeds the configured cache size, increase WiredTiger cache size GB, but leave at least 25% of RAM for OS and other processes to avoid OOM. Here are systematic recovery paths for common failure modes. For MongoDB, use getIndexes and explain to verify index usage. For Cassandra, use NodeTool-CF histograms to check partition size. For Redis, monitor memory and set an eviction policy. Let's run through some common interview questions. How does Cassandra handle node failure? Hinted handoff, CL equals quorum tolerates one failure. When choose MongoDB over PostgreSQL, need horizontal scaling, flexible schema, auto failover. What happens when Redis key expires? Lazy expiration, red returns nil, background timer deletes. And a few frequently asked questions. What are the 4 NoSQL types? Key value, document, column family, graph. Difference between document and column family? Document, self-contained JSON, column family, wide tables, range scans, MongoDB versus Cassandra, MongoDB for flexible queries, Cassandra for extreme write throughput. Key takeaways, key value stores are for simple lookups by key. Document stores give you query flexibility but fail at joins. Column family stores excel at write-heavy workloads but require careful partition key design. Graph stores are unbeatable for relationship traversal but terrible for aggregate queries. Ready to go deeper? Up next, LSM trees and SS tables, then distributed consensus, Paxos and Raft, then leader election. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.